So for these next two, what I'd like you to do is look at them. You're going to draw them in your notes and then try and name them. So hit pause on the video right now. Okay, you've got them named. So first things first, what's the longest chain we have here? 1, 2, 3, 4, 5 carbons. What do we call a 5-carbon chain? From table P, that's pent. And a 5-carbon chain, we look, does it have single bonds, any double bonds or triple bonds? Only single bonds, so that's an alkane, so we end it with anes. So we have our prefix and our suffix. Now we're going to see, is there anything on our pentane? 1, 2, 3, 4, 5. Is there anything on it? Well, there's this CH3 group and this CH3 group. A CH3 group is called a methyl group. So this is a methylpentane. Hope my spacing's okay. So we have methyl attached. Now, how many methyl groups are on our methylpentane? There's 1, 2 of them. So this is to signify there's 2 methyls. This is a dimethyl. And we then have to say, where are those methyls attached? Well, they're attached on, we want to go, is it 1, 2, the 3rd carbon and the 4th carbon, or is it 1, 2, and 3, the 2nd carbon, the 3rd? We always want to go with the shorter length. So we'd start with this being the 1st carbon, then the 2nd carbon, the 3rd carbon. So they exist on the 2nd and the 3rd carbon. So this is a 2, 3 dash dimethylpentane. So you'd read it 2,3 dimethylpentane, but that's the official way to write it using the IUPAC system. Okay, for the next one, what is the longest chain? Well, what you want to say is you want to say, oh, here's the longest chain. Well, just like a chain you wear around your neck, it can curve. So this you'd say is a 1, 2, 3, 4, 5 carbon chain, but it's actually not. This carbon chain starts and goes 1, 2, 3, 4, 5, 6 carbons. Or could it be 1, 2, 3, 4, 5? No, 5 is less than 6. Or it could be 1, 2, 3, 4, 5, 6. So we know that the longest chain is 6. You look at table P, and that tells you a 6-carbon chain is a hexane. So it's hex is for the prefix for 6. Ane is the ending because it's an alkane. It has single bonds. You know that from our other lesson. So we have a hexane. Now, where is there something special on it? Well, if we said this is the longest chain going this way, it'd be 1, 2, 3, 4, and we have this special group on it. So here's our special group. Now, this special group is a 2-carbon chain. This 2-carbon chain on our special group is, if we look at our prefix on table P, it's an eth. So this would be called an ethyl group. So a 2-carbon extra chain hanging down is called an ethyl. So this is an ethyl hexane. And does it exist on the 1, 2, 3, 4th carbon or the 1, 2, 3rd carbon, the 3 carbon? So we want to go with the shortest end. So we now have to read from this end right to left. So this would be on the 3rd carbon right there is where our ethyl group is. So this would be called, according to the IUPAC naming system, 3-ethyl hexane. So you're getting good at this, aren't you? How about drawing 2-methylbutane, the molecular structure? So let's see if we can get our structural diagram. Let's see if we can draw our structural diagram for 2-methylbutane. So how many carbons are in a bute? 4. 1, 2, 3. These are structural diagrams. So I apologize. I called them molecular before. Molecular is when you'd say this is C4H10. So methyl, we need to add our 4 bonds around every carbon, making sure we have stable carbons. There will be hydrogens at the end of these. So there's butane. Now on the butane, it says it's 2-methyl. That means on the 2nd carbon, there's a methyl group. So there's a carbon with 3 hydrogens. The molecular formula for methyl is CH3. So this is our structural formula for 2-methylbutane. This next one has 1, 2, 3, 4, 5 carbons in a row, or 1, 2, 3, 4, 5. Doesn't matter. 5 is going to be our longest chain. A 5-carbon chain is called pent for its prefix. You'll see all single bonds again. So this is pentane. Now on the pentane, is there anything special? So we have to go back and do a little detective work. If this is my first carbon, second carbon, on the second carbon, there's this group right here, which is a 1-carbon chain. That's a methyl. On my third carbon, there's a 1-carbon chain, which is a methyl. So there's 2 methyls on this. So 2 methyls is called dimethyl. I'm learning, left myself a little more room this time. So 2 methyls is dimethyl. And then we have to say on our dimethylpentane, where are those methyl groups on the second carbon and third carbon? So this is a 2, 3 dimethylpentane. So this one's a tricky one. We've got 1, 2, 3, 4, 5 carbons in this chain. So that makes it look like that's a pentane. And on the second carbon, there's a 2-carbon chain. So it looks like this should be ethylpentane, specifically 2-ethylpentane. But that's wrong. It's wrong because we have to find the longest chain first. And our longest chain is actually right here, starting with this carbon, 1, 2, 3, 4, 5, 6. So the longest chain here is a 6-carbon chain. So 6, the prefix on table P is hex. According to table Q, single bonds are alkanes, so we end it with ane for our suffix. So this is a hexane. So if this is our hexane, and we have our first carbon, second carbon in the chain, third carbon in the chain, that's a weird 3. Oof, that's an even worse one. Fourth carbon in the chain, fifth carbon in the chain. Oh, writing with a mouse pad really leaves something to be desired. And 6 carbons. So we have a 6-carbon chain. So on our third carbon, my gargantuan 3 there, we have this 1 carbon. So this is a methylhexane. So the trick here is they put a little bend in the carbon chain. So just like a necklace, we can have a bend in our carbon chain. They're not always straight. When we write them, we like to write them straight because that's just the easiest way to write them. But you know the Regents exam. They're going to write them crooked to try and mess you up. So this is a methylhexane, and that methyl group lives on the third carbon. So the IUPAC nomenclature is written so that we know exactly where things go. So it tells us, like your address. What town do you live in? I live in Hexane Town. What street? Methyl Street. Well, what number house? Third. You could find that exact address. So it's a hexane 6-carbon chain with a methyl group of 1 carbon on the third carbon of the hexane chain. The rules are similar when it comes to naming alkenes. Alkenes, we find the longest chain, 1, 2, 3, 4, 5. And typically we would start naming it for whatever end has a special group. But the double bond or triple bond, whether it's an alkene or alkyne, that sort of trumps everything, and that would be considered the most important part. So this is 1, 2, 3, 4, 5. This is a pent. So we name the longest chain. It's a pent. And we see there's a double bond. So this, when we look at table Q, double bonds are alkenes. So it ends in ene. So there's our suffix in ene. That signifies double bond. Now we have to tell where is the double bond. The double bond's on the first carbon. So this is 1-pentene. Now we're not done because this also has a methyl group right here. The methyl group is on the 4th carbon. So this is 4-methyl 1-pentene. So we have two special things on this one. So we have the name and the exact location of where the double bond is. And then we have the name of the special group, the methyl group, and where it's located. We separate that with a comma. So this is 4-methyl-1-pentene. So if we were going to draw the molecular structure for this bottom one right here, what's our longest chain? 1, 2, 3, 4, 5, 6. 6 carbons. So we have, what, 6 carbons? A hex. So this is hex. Is it double bonds or single bonds? On this one, they're all single bonds. This is a hexane. And on it, there's a special group here and a special group here. Those two special groups are the same. They're both 1 carbon, so they're methyls. So this is methylhexane. You're getting good at this, right? So methylhexane. Now there's 2 of them, so I have to signify it's 2. So this is dimethyl. And where do they exist? They exist on the 2nd carbon and the 3rd carbon. So we have our molecular structure 2,3-dimethylhexane. Now, what if we wanted to draw the structural formula for 2-pentyne? 2-pentyne. Now we see the ine on there. That means a triple bond. We have our prefix pent. So how many carbons in a pent? You look at table P, and there's 5. So we have 1 carbon, 2 carbons, 3 carbons, 4 carbons, and 5 carbons. So what can you tell me about the whereabouts of where the triple bond is for the ine here? It says it's on the 2nd carbon. So I can go to the 2nd carbon and say, all right, here's my 2nd carbon. I need a triple bond. So I'm going to draw on my triple bond. Then we have to fill in all of our hydrogens. So we have to make sure every carbon has 4 bonds. So this carbon here has 1. We need 2, 3, 4. How many bonds are on this carbon? 1, 2, 3, 4. So I don't add any hydrogens. How many are on this carbon? 1, 2, 3, 4. I don't add any hydrogens. Around this carbon, there's 1, 2. So we add 3, 4. There's our bonds for our hydrogens. This one has 1, 2, 3, 4. So we want to make sure we don't put too many bonds in and too many hydrogens. We have to count, make sure we only have 4 lines, 4 bonds around each carbon. Okay, we're up to our last slide of today's lesson. So what I needed to do is I need to write down the name 4-ethyl-2,3,4-trimethyl-octane. Once you've written down 4-ethyl-2,3,4-trimethyl-octane, you're going to pause this video and you are going to try drawing it. So you tried drawing it. I'll let you know a little secret. Back when I was in college, and even to this day, I love drawing organic compounds just because it's sort of like a challenge to fill in the puzzle. So to save a little time, instead of you watching my painless drawing of carbons and all the hydrogens, I drew the octane part. So the octane's taken care of. Now this says it is a 2,3,4 trimethyl octane. So that means on the 2nd carbon, there's a methyl group. And you could put them top or bottom, doesn't matter. On the 3rd carbon, there's a methyl group. I'm just switching it up to show you can put them top or bottom, doesn't matter. On the 4th carbon, there's a methyl group. So now when I look at my octane, I can see 1, 2. On my 2nd carbon, there's a methyl. On the 3rd carbon, there's a methyl. On the 4th carbon, there's a methyl. So 3 methyls is a trimethyl on the 2nd, the 3rd, and the 4th carbon. Now it also says 4-ethyl. So that means on my 4th carbon, I need to have an ethyl group. How many carbons in an ethyl group? 2. So we look at table P and we have the prefix ethyl for 2 carbons. Now we need 4 bonds around each of those. So this one would need 2 more. And this one right here would need 3 more. So now we have 4-ethyl 2,3,4 trimethyl octane. Now the ethyl comes before in the word, first in the word, because when we have multiple groups, we have to put them in alphabetical order. So alphabetical order-wise, E comes before M. So ethyl before methyl. So this is a 4-ethyl 2,3,4 trimethyl octane. 4-ethyl 2,3,4 trimethyl octane, 8 carbons. Nice work. These are fun to do. Your Google form quiz at the end is going to have 8 of these drawings, and you have to name them. So hopefully you got good at it. Keep table P and Q out.